Hey, here's a quick video on how to solve 4 through 6 on our 1B geometry 7.2 to 7.4 review. Now, the things that I really need to know, I need to know my parallelogram properties. So things like the opposite sides are parallel and congruent. The opposite angles are also congruent. I need to know that the consecutive angles add up to 180. I need to know that the diagonals bisect each other, and I put in an extra box here. So if you wanted to include that the opposite sides are parallel, you can, but since it's kind of the definition of a parallelogram, that the opposite sides are parallel, then you really don't need to include it. So I need all those properties. I should also be considering the rectangle properties, that the diagonals are congruent. And I have 4 90-degree angles. So let's always mark in our 90-degree angles. And I should mark in what's given, excuse me. So JL is 13. So this here is JL. That's segment JL. That's 13. Which means that each side, since these diagonals are bisected, would be half of 13, which is 6.5. MK, the whole, let me color code this whole diagonal MK, the other diagonal is 7x minus 1. So I have one diagonal is 13, the other diagonal is 7x minus 1. Well, what do I know about the diagonals in any rectangle? Well, one of my very important rectangle properties, one of the first ones we learn, because it's so useful in construction and in measuring and in trying to, whether you're putting together a bookcase or a house or a car, whatever you're doing, you need to know that the diagonals should be equal. Well, these are my two diagonals, JL and MK. And if those are my two diagonals, then they should be equal if that's a rectangle. So JL should be equal to MK, or 13 should be equal to 7x minus 1. So now I can solve for x. 7x should be equal to 14 if I add 1 to both sides, and x would be 2. Now solving for y, let me erase some of this extra information here. Solving for y, angle JKL. Now we also need to know how to name our angles, how to identify angles. Well, JKL, that means that I'm starting at J, I'm going to K, and I'm ending at L. So the angle that's really being marked in here is this one. That's angle JKL. So I start at J, my vertex, or the corner, is at K, and L is the other side of the angle. So I have the angle really at K. And what is this angle measure? Well, if it's a rectangle, it should be 90 degrees. So the measure of angle JKL should be 90 degrees if that's truly a rectangle. It also says that the measure of JKL equals 2y plus 76. So hold on, it equals 2y plus 76, but I know that that angle is really 90. I know that JKL really equals 90. So I can take that information and say that 2y plus 76, well, that should be the same as 90 degrees because that corner there at K, angle JKL, is 90. So now when I subtract, I get 2y is 14, or y should be 7. And our last problem here, problem 6, that we're going to talk about on our video. We're going to take a look at rhombuses. Now, rhombuses have all the properties that we listed for our parallelograms. So these properties still fit for a rhombus. The extra rhombus properties are that you have 4 equal sides. You have the diagonals form a right angle. They're perpendicular. And those same diagonals bisect the angles. They cut those corners in half. So we're given here, let's see, what did I put here? I put 3z plus 20, and I put 7z minus 8. I'm given that PS is 25. Actually, let me do that in a different color. I'll do it in green. PS is 25. PTQ is 5x. So this angle, PTQ, that means I start at P, I go to T, I go to Q. So this angle here is 5x degrees. And SR is 2y plus 9. So let's start with x. What do I know about the middle angles in a rhombus or a square? What do I know about this angle measure here? Well, if I go back to my properties that I listed out earlier that I should have memorized for the quiz, I can see that the diagonals are perpendicular and they bisect those corner angles. Well, that's not in a corner, so that last one doesn't really count. But they're perpendicular. What does that mean? It means they form a 90-degree angle. So that means that in a rhombus or a square, that's 90, that's 90, that's 90. So this must be also 90. So 5x should also be 90. Or x would be, let's see, 90 divided by 5 would be 18. So 5 times 18 would get you 90. Solving for y, let me erase some of this extra stuff here. Let's focus on y. Here's y. That's the side. So SR is a side length in a rhombus. Let's go back to my properties. What do I know about a rhombus's sides? Well, all 4 sides, it says, are equal. So let's look for some other sides. I don't know what this is. I don't know what this is, but hey, that's 25. So if this is 25, then that's 25, and QR is 25, and SR should also be 25. So I can say that 2y plus 9 equals 25, or 2y equals 16, or y would be 8. And then for z, why don't you try to solve for z on your own? I would again look at those properties that you listed out. I would encourage you to pause the video, try it, and then unpause to check your work. Alright, so the angles are being bisected or cut in half by those diagonals. And anytime you cut something in half, the 2 halves by definition are equal. So 3z plus 20 should have to be equal to 7z minus 8. And if I do some algebra, I'll get 28 equals 4z, so z should be 7. Let me know what questions you have, and I will see you soon.